these things will be counted, right? These things will be counted. For this, I have drawn a tensor board. So it will throw a board for me as a tensor flow. So I will get number of the epochs, are also called as a smoothing curve. To get this curve in terms of the epochs, x-axis as the epochs and y-axis as a loss, so that I will conclude that which epoch is going to be give as the less loss, or which epoch is going to be give as less number of the loss with corresponding to the train error and also the test error. So that I will conclude which epoch is going to be helpful, I will run those epochs. That's it. So no need to worry about how many models you are going to be implemented at the time. You have to be worried about which is going to be helpful, which not going to be helpful, by using the smooth approximation of the TensorFlow. So let's go and check out that how does this is just a summary of your model. That's it. Yeah, if you go down, yeah, you can see we are just comparing the data. Yeah, if you go down, you can see this tensor board. So the tensor board it's going to be give with regarding the some of the smoothingness curve. If I pass this curve according to whatever the values I required, you can see the more number of the models is going to be computed together with corresponding the train and test results. So yeah, let's go a little more. Yeah, you can see here the train and validation results are validating with corresponding to the value of 0.6. Yeah, 0.6. Yeah, I hope it's visible. Just a second. Yeah, so the value is going to be visible for 0.6 for the train, 0.62 for the validation loss. So according to that, I will get to know the more number of the epoch at worst, it very worst for the first epoch. What will happen if I smooth this curve again and again? So it will be slightly going to be change the value. And what will happen if I smooth this curve again? It's slightly going to be much higher for the validation only, not for the sorry, this is for the training, not for the validation results. Validation will not be appearing at the time, still it's the same phase only. Slightly maybe correlated somehow to get more number of accuracy results. This is accuracy, this is loss. You can say this is loss. Even you can also see the headings: epoch versus accuracy, epoch versus loss. You can trial out with the learning rates, everything is there. Okay, I mean iteration process you want to be counted, batch processing, and you can also go with some of the graphs if you want to visualize things. I think it's reloading maybe. Yeah, it's also very useful. Try to learn from the TensorFlow. This is very helpful, I can say. The main drop, it's loading maybe. Yeah, you can also use coloring kind of the thing, and also the distributions you want to be showcased. Some of the distributions are going to be helpful to understand with regarding the train and also the loss results. So what will happen eventually if you take this tensor bond play around to get good minimal loss and good accuracy results? I think, yeah, just a second, we can smooth somehow. Yeah, still it's not clear. No, maybe left side. No. Something within that. Yeah, eventually what will happen, you will get good fitting of this model smoothing. No. Yeah, you can also use this one maybe. I think it's going to be get some different value. Not reach. Still not reached. Yeah, it will be reached. Still not reached. Yeah, it will reach now. Yeah, you can see it's correlating somehow that point. I think we will get this. No, still not. Yeah, you can see the score of the accuracy results with this uh, epoch second. So you can see here the epoch 7 consists of zero point 0.7 results for the for the trained data set. For the validation data set, we got 73 percentage. And what about the loss? So this will update it, I think. This is going to be updated. No, still it's not reachable, I think. Okay, you can smooth maybe a little bit. Yeah, yeah, it's okay. Yeah, it's okay. So the value for corresponding to the train, it's slightly higher when compared to the validation loss, right? So so these things will matter because we haven't not done on top of this as a data augmentation. If you're done with data augmentation, it will be replicated with respect to the train data set is high when compared to the loss data set, I mean validation data set. You can play around with this in the cn this pizza kind of the work. So this is much appreciated, I can say. Whenever you do the tensor board, this is very easy to understand while doing and comparing with the smoothing curve with respect to the accuracy and also the loss results, instead of doing model 7, model 8, model 4, model nothing. So you can directly go with the tensorflow, and you can also probability to learn by using early stopping. Early stopping we can also discuss, that is much appreciated work and hack also. So you can also plot by using, you want to be showcase model plot, you can directly plot like this. So there are so many different libraries to showcase in the deep learning. We can plot, we can visualize the things, we can appreciate by using the pre-trained mechanisms whatever they implemented corresponding to, we can track the APIs and working together as a TensorFlow concepts. So we'll go and detailedly discuss about the VGG16 tomorrow, VGG16, and I will also explain corresponding to VGG16 to implement on the pizza project. So that we'll go and discuss with the pizza process remaining work with regarding the multi-class classification with